Adding HVAC systems to the energy model will increase its complexity. For now, we have turned on ideal air loads. So we will just run the energy model and resolve simple errors first before we start adding more complexity to our model. Let's go to Simulation Settings and Time Steps. This sets the number of iterations that the program runs the energy model per hour, the number of iterations per hour. Right now it is set for 6 time steps per hour, so it simulates the building basically every 10 minutes. Let's reduce this down to 1 time step per hour, and this will speed up our calculations for now. We can always come back and adjust this later. Next, let's go to Measures. And one thing we're going to want to do is add Diagnostics to the Measures tab. To do that, go to the right and select drop-down Reporting, drop-down QA/QC. And then we will select this Add Output Diagnostics. If you do not have it, simply go to the bottom and click the Find Measures on BCL button. Browse to Reporting, QA/QC, and search for Add. And you can find it right here, Add Output Diagnostics. You can see it's checked because I've already downloaded it. If you do not have it, it will not be checked, so check the checkbox and click the Download button. When you're done downloading, drag and drop the Add Output Diagnostics to the Energy Plus measures. This adds additional diagnostics when running the energy model to troubleshoot problem areas. Next, we will go to Run Simulation. Click Save and hit the Run button. You can see that the simulation has failed, and there are various errors associated with a failed simulation. This will be a good exercise. First, browse to the folder where your energy model is located and open the program folder and browse to Run and select the E+out error file. Open it with a text editor. There are two different types of errors. There are warning errors and there are severe errors. Severe errors will terminate the program before it has finished modeling the building. Most of these are warning errors. So first of all, let's address the severe errors. Scroll down until you find a severe error. You will note, here's the severe error. This says we are having a convergence problem with one of our building materials, roof metal building. This is one of the assemblies that we created earlier in the process, if you'll recall. Let's go ahead and take a look at this and troubleshoot this. Go back to your Materials tab on the left. Go to Materials tab. Drop down Materials, and we will browse for thermal break, purlins, and insulation. These are the two materials that we created. Look at the thermal break, and we'll take a look at what our calculations were for the insulated value. The thermal break is 0.1667 and 1/2 inch thick. And the purlins and insulation, should be 0.335. That should fix the severe errors. Double check that you don't have any other additional severe errors. We only have one. Go ahead and close the error file. Save the project and rerun the simulation. Success. So we did have a proper simulation. However, there were several errors in the error file that we noted prior. Let's go back and look at the error file again. There's warnings. The first warning, requested number 1 time steps is less than the suggested minimum of 4. This is saying that the program recommends using at least 4 time steps per hour. We will ignore this one. Next, let's look at the next warning. This has to do with our cooling HVAC default schedule, and it looks like these are similar. The fire station locker occupant schedule, and it looks like these schedules are not falling within our time step. If we go back to the locker schedule as an example, you can see these time steps are in very small increments. Small enough that they start and stop within the hour. But if you recall, our simulation settings were set to simulate every 60 minutes. So our simulation settings time steps are not small enough to capture the on-off nature of this schedule. That's what this error is saying. So we can ignore that. Similarly, the same thing goes for the microwave schedule. The next warning is always on, always off, and always on continuous. These are integral to the OpenStudio program, so we can't edit these. We will ignore these warnings. The next warning is saying that there were no ground surface temperature schedules associated with our energy model file. So the program will be using the default constant temperature throughout the year, which is 18 degrees Celsius. That is not concerning. Let's go on to the next warnings. These are check convexivity warnings, collinear points. This is saying that some of the vertices in our model have been doubled up. Energy Plus does not like to have vertices doubled up on top of each other. So for simplification, Energy Plus deletes some of these vertices. We don't have to worry about that. Next, let's look at the next warning. It says there are 9 nominally unused constructions in input. Some of these constructions are not being used inside our model. Interior windows, partitions, and doors. We don't have any of those in our model. Let's go back to the Construction Set tab. We do have exterior walls, floors, and roofs. We do have interior walls, interior floors, and interior ceilings. Ground contact surfaces. We don't have any walls in contact with the ground, so we can delete this. We do have interior floors that are in contact with the ground. We do not have ceilings in contact with the ground. We do not have operable windows. We do not have tubular daylight domes. We do not have tubular daylight diffusers. And we do not have any interior windows or doors. And we do not have any interior partitions in our project. So we can delete that as well. Next, go to the Constructions tab, and we can simply go through and purge unused objects. Select each one of the categories and click the Purge Unused Objects button. Next, go to the Materials tab and do the same thing. This helps get rid of some of the clutter in our project and speeds up the simulation. Save the model. Let's continue on with our errors and warnings. This warning says that we're having comfort-related issues, but there is no comfort model selected. This is for small hotel laundry. We are also getting the same issue with the locker room. To fix this issue, let's go to the Space Types tab. Go to Loads. And this has to do with occupancy schedules. Aha. In the laundry room, the decontamination room, we have a laundry occupancy schedule that shows work efficiency schedule, clothing insulation schedule, and air velocity schedule name. If we select our load definition, you will see that we do not have any comfort analysis selected for this. Click the plus button and drop down thermal comfort model type, and we will just select the first instance. This has to do with the laundry and the locker room. Outpatient, fire station locker room, plus that should solve those two warnings. Let's continue with the additional warnings. This warning is saying that the office corridor zone does not have any exterior walls, so it cannot calculate an infiltration value. You would have to do a different infiltration value for that type of space located on the interior of the building. Let's look at it. Corridor, people, infiltration. Right now it's selected as a flow per exterior area value, but you can change the infiltration value to flow per space, flow per area, or air changes per hour to ensure that that space receives some form of infiltration. But we can just ignore that error. Same thing goes for the other interior rooms, locker room, the restrooms, and the storage room. Let's look at the next warning. Calculated design cooling load for thermal zone is 0. Thermal zone 101. Let's go to our thermal zones tab. Thermal zone 101 actually does not have a cooling thermostat schedule, but it's trying to calculate cooling. So what this program is saying is that with no schedule, with no thermostat, the cooling load would be 0. Let's continue on. Same issue. Ideal air loads is trying to calculate a cooling load, but there is actually no thermostat associated with that space. Let's look at the next issue. This is saying that there are multiple electric meters, so it will report both meters. Let's go to the next warning. These warnings have to do with life cycle cost analysis. It's saying that it does not have any energy costs inputted into the model. We can ignore those warnings. Next, let's go to these other errors. This says there are 10 unused schedules in the input. To look at those schedules in Output Diagnostics, we would have to select Display Unused Schedules to see them. Let's do that. Going back to the model, click Save, go to Measures, select Add Output Diagnostics, click the drop-down and select Display Unused Schedules. Save, and let's run the model again. Next, let's go back to the error file, open it, scroll down to where we left off. Following schedule names are unused schedules. We are not using always off, laundry equipment gas schedule, we can go back to our energy model, go to the Schedules tab, select Schedule Sets tab. If we go to the storage room, you will note that the storage room has an occupancy schedule associated with it. But if we look at our Space Types tab and go to the storage room, you will note that there is actually no occupancy assigned to that room. The same situation goes with the apparatus bay. Going back to the Schedules tab, we can get rid of those. Go to the storage, remove the occupancy schedule, and we will not need activity schedule. And there is actually no electrical equipment in the storage rooms. We can remove that as well. Going back to the apparatus bay schedule set, We do not need the occupancy or the activity schedules. Next, go to the Schedules tab, and we can go through and purge all of the unused schedules using the Purge Unused Objects button. Click Save and rerun the model. Let's go back to the error file and scroll down. This is still saying that there are some unused schedules, but again, these are the schedules that are integral to OpenStudio, so we can ignore those. They're not being used anyway. Next, if we look at this warning, these are unused schedules. They're not being used. This is the clothing schedule that we created in the first place. Let's go back and look at that schedule. Go to the Schedules tab, Clothing Schedule. Let's troubleshoot this. We have not applied this schedule to any days of the week. We do have it applied through a date range, but we do not have it applied to any of the days. So we can select all of these days to make this applicable. Let's look at Schedule Rule 1, do the same thing. Save. And that should complete all of our errors. Let's rerun the model and see if that fixed our problem. This is a good exercise. With energy modeling, there is always troubleshooting to be done. Go back to the error file, open it up, and scroll down, and it looks like that solved our problem with the clothing schedule. These final warnings are saying that there is a surface, but it does not completely surround the subsurfaces. And this has to do with our doors, because the doors touch the very bottom edge of the surface. They're only surrounded by 3 sides. So we can ignore these errors. these warnings. And this gives you a summary of all the errors and warnings. Really, the key problems are the severe errors that will stop your program. Some of these warnings are not very problematic, and some of them will help you ensure that your model turns out the way you intended it to be. Let's close the error file. And we can go to the results summary to finally see our results for the model. We will go through this in the next lesson. Thank you, and please like and subscribe.